Okay, we're going to talk about types of reactions. So imagine you're preparing a cake from your favorite recipe and you discover that you've run out of a few ingredients. If you know that there are patterns in the way that some ingredients are mixed together, you can make substitutions for the missing ingredients. For example, yogurt can be used instead of an egg to increase the lightness of a cake. So in similar ways, chemists know that there are patterns to ways that certain elements and compounds go together. They use these patterns to group different types of chemical reactions. Grouping chemical reactions is useful for several reasons. First, it allows chemists to predict the product of an unknown chemical reaction. Second, it helps them to understand the behavior of substances in a chemical reaction. So in the following, we'll discuss the 4 basic types of reactions. So simple composition reactions. So when magnesium is ignited in the presence of oxygen, a simple combustion reaction is the result. So during this reaction, there are 2 reactants. The first one is magnesium and the other is oxygen. So if you held the magnesium in the flame, you might observe the reaction taking place. The resulting product would be the compound magnesium oxide. The reaction would also produce energy in the form of bright light. So the word equation for this reaction is magnesium plus oxygen goes to magnesium oxide, light, and thermal energy. So in a simple composition reaction, 2 or more simple elements combine to form a compound. So whenever you see 2 elements as reactants, you know that the reaction is a simple composition reaction. So in a simple composition reaction, the product is always a compound. So if we use the letters A and B to represent 2 different types of elements, the simple composition reaction is written as element 1 plus element 2 equals compound, or A plus B equals AB. So simple composition reactions are exothermic, meaning that they give off some form of energy. It is wise to know about this type of reaction before you try it in the lab. So then we have simple decomposition reactions. So during electrolysis, water is broken down into hydrogen gas and oxygen gas. Electric energy is needed to drive this reaction. So it makes it an endothermic reaction. So the word equation for this reaction is water plus electric energy gives you hydrogen gas and oxygen gas. So the reaction that breaks the compound into its component elements is known as a simple decomposition reaction. So whenever you see a compound as the only reactant, you know that the reaction is a simple decomposition reaction. So in simple decomposition reactions, the products are always elements. So if we use the letters C and D to represent 2 different types of elements, a simple decomposition reaction is written in this way. So we have compound will go to element 1 and element 2. Or CD will turn into C and D. So most composition reactions are endothermic, meaning energy is absorbed. You've already learned about composition reactions in which elements are put together, so you also know something about decomposition reactions in which the compounds are broken apart. So they're kind of reversed or inverses. Combustion reactions. So when we light a candle, the candle wax burns in the presence of oxygen to produce carbon dioxide and water. This is one example of a combustion reaction or burning. Combustion always occurs in the presence of oxygen. Combustion also occurs when you burn the fuel to power a car. The word equation for the combustion of gasoline or octane is octane plus oxygen gives us carbon dioxide and water vapor and energy. And the same type of reaction occurs when you light a butane lighter. The word equation in this case is butane plus oxygen gives you carbon dioxide, water vapor, and energy. Oil and natural gas are fossil fuels. This means that they come from the accumulated remains of plants and animals from prehistoric times. Fossil fuels form very slowly, which is why many scientists believe that we will run out of them. We use them up so much more quickly than they can form. Finally, we have neutralization reactions. So taking an antacid for release of acid and digestion is an excellent example of neutralization reaction. In a neutralization reaction, the acid reacts with the base to form a salt and water. So the word equation for a neutralization reaction is acid plus base turns into salt and water. When you take an antacid, the magnesium hydroxide in the tablet reacts with the hydrochloric acid in your stomach. This neutralization reaction is written as hydrochloric acid plus magnesium hydroxide, which is our base, turns into magnesium chloride or our salt and water. So you may be surprised to know how many neutralization reactions occur around us every day. These are involved in many natural and household and industrial products and processes. Thanks for listening.